Hello everyone, I'm Carius, and today we're going to be talking about gluing PLA 3D printed parts together. For the longest time, I was under the impression, and I believe several other people in the hobby are under this impression as well, that there wasn't a way to solvent weld PLA together. But it turns out that's not the case. There is actually a pretty readily available solvent that will melt PLA plastic together. Now, in a lot of cases, if you have a PLA 3D printed part that fails, you're just going to want to reprint the part. But for some cases, it's much easier just to glue it back together. Or if you have a multi-part print that you want to join together more permanently, or you had a pretty long print just fail at a single layer that is otherwise good, it might make more sense to just glue it instead of having to reprint the whole thing. Or if you want to join two different colors of PLA together, this will be an easy way to do it. Now here I have kind of a pile of failed prints and other crap to experiment with. A couple failed blowgun end caps and mouthpieces, and some parts from the double caliburn that didn't quite make it, and a Spring Thunder piece, and even a piece off of my Lynx that spaghettied the first time I tried to print it. And we'll see what we can do as far as solvent welding this stuff. So the solvent in question is Grip 3. It is meant for styrene and polycarbonate, but it works really well for PLA. It is dichloromethane. So any glue or epoxy or solvent that contains dichloromethane, or called DCM sometimes, will actually glue PLA together. As with all solvents like this, it's pretty toxic. You want to work with it in a ventilated area, probably wear a mask, try not to breathe it in too much, kind of all the standard warnings for working with chemicals like this. I found it works pretty well for gluing together PLA. Now you can use one of these little syringe bottles that usually come with stuff like this, or I found that just using a Q-tip probably is a little easier to apply the stuff to print parts. Here's a kind of standard case of something where it had one really bad layer that just broke in half, and I'm going to see how well it can just be glued right back together. Just kind of applying it to the part. And it's very thin. It's like non-gel super glue or other solvents, and you just want to apply a bit to both surfaces, and you can see it's sticking to the Q-tip pretty bad, and putting a little bit of cotton in there, but that's fine. So we're going to do that, and I've noticed that it takes a little while to dry after you've done this. I usually wait an hour and come back to this kind of thing, and you can tell it's like bonding immediately, but the actual plastic itself is still a little gooey. It's still kind of melted, and it takes a while for that effect to go away. So you need to leave it to dry, but it is already pretty well bonded. Like I can't actually pull it apart anymore. So it'll set really quick, but you notice especially on the surfaces where, if you have any runoff, it'll still be kind of tacky and melted, and you'll just need to wait a while for that to dry out and become completely solid again. But yeah, this is, if I like try to break this, you can see it trying to open up, but like on the other side it's already completely melted together. And you can even get a better bond by just kind of applying it to the cracks where it's still kind of opening up, and it will just melt everything together. But it will take longer to dry. So you'll definitely have this surface on the outside that has been slightly melted, and it'll just be kind of tacky to the touch, and you can dent it pretty easily with your fingernail, but it will solvent weld PLA. So yeah, seems to work really well. I used it, actually, the whole reason I looked into this and discovered DCM in the first place was some parts on my double mega burn. You may remember that I was having issues with the handle piece here where the catch connects that had split along the layer lines in a couple places because I had over tightened the screws. And instead of having to reprint this entire handle, I put a bit of DCM in the cracks and clamped it, actually with just one of these clamps against the table. And now you can kind of see it is completely closed up and glued together, and it's pretty strong. And it even has a little bit of squeeze out of melted plastic from where it was clamped for a while, and I just let that dry, and now it's completely solid, and I didn't have to reprint this whole handle. It's actually maybe stronger than if I had just printed a new part, because this piece is now solid and doesn't have any weak layers to split open on me. So that's pretty cool. I've also used it to repair a flywheel cage. Not this one specifically, this is just for a visual aid. I had an entire motor mount come out of a flywheel cage, like break against the layer lines, because I had shoved in a motor a little too hard, and when I was putting the flywheel on it and messing with that, the whole motor mount just ripped off the cage. But I was able to, with some DCM, just glue the motor mount right back onto the cage, and it was strong enough and glued to it cleanly enough that I could then just put the motor and flywheel in like normal, and the blaster that flywheel cage is in works perfectly fine, as if there was no breakage of the cage in the first place. So that's pretty awesome. And that particular cage that I repaired was something I didn't have the file for. I had ordered it from somebody, and I broke it just being a little too rough putting the motors in. So it was really nice that I could repair it without having to go back to the guy who printed it and be like, okay, I need another one because I broke this one. So that was fortunate. Let's do a little bit more gluing, see if we can get some dissimilar parts and surfaces to stick together. Here we have a very badly failed print where the nozzle got clogged toward the end of a piece of a Spring Thunder. And I'm just gonna stick this muzzle piece right on the side of it and see how well that works. Just kind of put it all over the surface and see the Q-tip getting a little red because it is melting the plastic here, or dissolving it, I guess would be a more correct term than melting. The initial application of the chemical seems like it dries really fast, so you will want to work quickly. It's just the weird tackiness that happens to the part takes a little while to go away. So let's see, I'll just clamp this just to make sure it has some pressure on it, and give that a, I suspect that it's already fused solidly to this, but just to be safe and make sure it really bonded, you'll want to do something like this. Put some weight on the part if you can, or clamp it together just to make sure it has time to really bond and dry. And we'll do something else here. These parts were not meant to be put together either, so I'm going to do that anyway. And I'll try actually just applying it to this one part and not both surfaces. This is like a really weak bond of two surfaces that aren't flat. It's basically just stuck at these four little lines where these two pieces are coming together, and it's kind of an awkward weld, and I just want to see how strong that ends up being. And I only applied it to this part to see if it was enough to actually meld with this. because normally you want to apply it to both surfaces being glued together, but I want to see how strong it is just being applied to one. I'm going to hold this. Don't have another clamp handy right now. Well, this one's probably actually done. That seems pretty well stuck on there. So I'll use this clamp on this piece now, and we'll see what we got here. Yeah, it's like it looks like if I wanted this to be super strong, I should have used a little bit more DCM, because I can see it lifting just a little bit on this side, but that's on there. Like, I would need to hit this with a hammer to break it off here. Oh, no, there we go. Okay, you can really see maybe it wasn't melted quite enough. There's like specific spots where it was kind of bonding. So it looked like I needed to apply a little bit more, or maybe give it more time to dry. And this surface is still like really weird and tacky, but it wasn't, based on the kind of spots you can see here on the welded surface, it looks like it wasn't enough to like really melt the surface, or maybe I waited too long to join them together. So let's do it again. Because why not? If I just do that, stick it on there while it's still definitely wet, and kind of just apply a little bit more to the outside edges where the surfaces are touching, just to kind of melt it and make sure everything is being dissolved together. See if we can get a stronger bond here. I want it to be as if this is one solid piece, which I believe is more than possible based on how this has been working so far. Something heavy. This drill works. We'll do this. Just balance that on top of there. Move that over to the side. I want to see if this weird glow-in-the-dark stuff that I use to print my links is actually gonna bond strongly enough to other PLA, or melt enough. And I'll do it, I'm gonna just glue it kind of like this, so we have a very small amount of surface area to work with, because I want to see just how strong it is doing that. I've kind of applied it, a decent amount of it to the edge here, and just stick it on there. And if you're gluing something, like, or if you're designing a part to be glued together in different colors, for example, it's probably a good idea just to take a little piece of the PLA filament of both of those colors and kind of just dip them in the DCM and stick them together and see how well they bond as a test piece before actually printing something and then risking melting it weird and not getting the kind of bond you're expecting. But this seems to work on several different PLAs, and supposedly this is for polycarbonate as well, so you might even be able to bond PLA to polycarb, which would be interesting. Okay, if I lift, whoop, that's on there. If I give it just a little bit longer to dry, that seems to be pretty solid. This piece is on here. Yeah, I can't break that back off with my bare hands, I don't think. I can hear it creaking, but I wonder if that's another one of these weaker layers, because this was just a bad print. You can see a lot of gaps, but the main one that actually broke is just not coming back apart. I hear it creaking like it's trying to, but no, that's not going anywhere. Cool. You would need to basically re-break the plastic to break this off at this point, which is pretty cool. That's really solid. Let's take a look at this one. Let's see what we got here. Oh, okay. Yeah, that's similarly solid. That's not going anywhere either. Oh, just as I say that, comes right off. So it seemed like it was glued pretty well, but definitely, yeah, I suspect that if I had let this dry for an hour or so, it would have been really solid, because like some of this piece actually came off onto this piece, you can kind of see. So it was still a little gooey, and I kind of ripped it back apart. So if you got something delicate like this, I think you'll probably be fine if you just actually give it some time to dry, and then it'll be pretty solid. Because that was pretty hard to break. Did not give it enough time to dry, so oh well. Same with this. It looks like it's pretty solid, but I can hear it creaking, and I should definitely just give this some more time. I'm gonna let this piece and this piece dry for a while and come back to them and see how hard it is to break them. Obviously, the best possible scenario for solvent welding like this is two flat surfaces, especially something where it's broken along the layer lines and it has a lot of surface area to melt back together. And this has had the most time to dry also. I want to definitely try. Yeah, these are two flat surfaces. Like, these are both from the print bed. So I want to glue these two together and see how strong that is. Coat this surface, get it kind of tacky, really blob it onto this surface, and then take these, stick them together, clamp them, and then I will leave this piece for an hour as well and see how strong this is after just a really quick glue application and then giving some clamping force for a decent amount of time. You want to make sure this is sealed up because it's a very thin chemical that will leak out like crazy if not like really tightly closed, and you'll end up with it evaporating and you'll lose a lot of the solvent that is semi-expensive. Like a smaller container of this stuff was like $20. I forget how much this Sagrip 3 larger can was. I've just had it for a while. I've had it for years actually, and I had no idea that it could be used on PLA. I think I originally bought it for polycarbonate, and it works pretty well for that too. Okay, I'll come back to this in an hour and see what has happened with these pieces. Okay, so it's been about an hour. Let's take a look at these. So we have our very flat surface to surface bond here, and I cannot pry those apart. Seems like they weren't even perfectly flat. Like you can see there's a gap here, but on the other side where they're touching, it's one solid part now. This is not gonna break. Let's see, where do I have? What happens if I hit it with a hammer? It just flies away. Is that shock enough to mess with it? I can feel it creaking. Oh no, I've actually broken one of the layers on the black piece to where it's wanting to just rip a part of the black piece off. That's pretty funny. But it's still not coming apart. Yeah, that is one solid part now. This one is probably going to be easy to tear off by hand. Oh, that's pretty strong. Just pulling it in tension, it's not going anywhere. Wow, okay. That's on there. I'm sure if I hit it with a hammer, it would break right off. But, that's pretty solid. Yep, there we go. It took a decent amount of force, though. But it was only on there, but just these two thin lines. But it definitely bonded. So if you had more of a flat surface, that would be really solid. What about this one? I was able to pry this off with my hands earlier, but this time it is very solid. Can I do the same thing here? Yeah, I'm sure if I like braced this against something and then whacked it, I could get it to come off, possibly. I'm gonna hurt myself doing that, apparently. Wow, okay. That is solid. That is basically one part. I would have to be just breaking the plastic to get this off at this point. I put this on the edge of the table, like that, or the table was up against this, and then I hammered the red part, and it stayed together. I didn't hammer it like super hard, but hard enough that if you were to have super glued this together per se, like that would have ripped right off, being hit with a hammer like that. And one other thing I did, and I'm just messing with the glue some more. For one, I glued these two parts together. They're probably not super strong because it's like the surface wasn't super large, and it's kind of pulling apart. It looks like it was only really bonded at this one corner, so you can see it flexing, and yeah, and it just breaks. And you can see exactly where it was glued together, where it got melted, but the surface just wasn't. There wasn't enough surface to really keep these two pieces together, but it was still fairly solid. But here's the cool thing. I took a few scraps of polycarbonate that I had and glued those to this piece of PLA, and they are on there. That's really solid. Like I'm sure I could snap this off, but like the entire PLA part is flexing rather than let this thin piece of polycarbonate break off. So using DCM, it is very possible to fuse polycarb to PLA. So that's pretty cool. Not sure what the application of it is just yet, but I mean, I'm sure somebody could come up with something. And this was just a disaster print. There's a rail piece of my caliburn that like the bottom printed, and then the whole thing shifted over, and then it kept printing. And by the time I got to it, we had this weird half printed thing, and then a big spaghetti mess, and then the rest of it printed, which is kind of funny. Wow, that's on. Yeah, that is very solid. It is fused onto that plastic. So cool. PLA solvent welding is a thing. It's pretty easy to do. There's a few different applications, and for anything where you really don't feel like reprinting a part, or if you wanted to fuse two differently colored PLA parts, or even add in some polycarb onto something, that is very possible. Alrighty. Well, that's it for today's video. I just wanted to show off something that seems like a lot of people in this hobby weren't aware of being a possibility. I know I wasn't. I was under the impression that there wasn't a good solvent for PLA, but apparently there is, and it works really well, and it even works with polycarb, which is pretty cool. So that's it. Thanks for watching. I'll see you in the next video, and until then, this has been Carius reminding you to have fun.
Meow. They have very different meows.